Hi. This video is just to talk about a forward reversing control circuit and the three different types of interlock that we're going to see in them. Now there's two interlocks that we're going to see in every single control circuit. So one of them is called the mechanical interlock. The mechanical interlock is actually a physical connection between my forward and reversing coil. Now that mechanical interlock, it actually prevents both armatures from pulling in at the same time. So it's a physical teeter-totter in there. Basically what will happen is one contactor will pull in, now the other one physically cannot pull in. So mechanical interlock prevents both armatures from pulling in at the same time, which is going to prevent line-to-line shorts. So that's our mechanical interlock, and we'll see that in every forward reversing contactor. The other one that we're going to see in every forward reversing contactor is called the electrical interlock. Now the electrical interlock is actually using a set of contacts, so we'll have auxiliary contacts on that forward reversing starter. And these electrical interlocks are placed in the opposite circuit, and it's to prevent both coils from energizing. So what I mean by that is here in my forward circuit, we would actually see a set of contacts, normally closed contacts, controlled by my reverse contactor. This way, when my reverse contactor is energized, this set of contacts opens and it prevents you from energizing the forward coil. And then we would have the same down here. In my reverse circuit, we would have a forward, normally closed electrical interlock, so that when my forward energizes, this set of contacts opens and it prevents my reverse coil from energizing. Now the key here is we're preventing the coils from energizing. Right, so I understand that we have our mechanical interlock, so if it was running in forward, the reverse coil or armature would never pull in. But if you were to press the reverse button, you could still energize that coil, which we know with an open jammed armature could cause a lot of damage to the control circuit, to the coil itself. So we require both electrical and mechanical interlocks in all forward reversing circuits, just for safety. Right, so that's where our interlocks would be. Now the other thing that we can have in a forward reversing circuit, so those we'll always have, one thing we can have is something called push button interlock. Right now, as this circuit sits, if we are running in forward, press the forward button, running in forward, closes, no problem. If we wanted to run into reverse, we would have to press the stop button, stop the circuit, and then we could start it running in reverse. For the majority of applications, that works great, and it works no problem, and we're happy with that. However, there is certain electrical applications where we'd want it to go from running one direction to immediately stop to run the opposite direction without pushing a stop button. So think about like a commercial garage door circuit or something like that, when you press the button and it changes directions immediately and goes the other way. How we do this is we use push button interlock. So these are all just standard push buttons, but if we think back, we talked about a push button before, and it was a button that looked like this. Now this button has a normally closed set of contacts and a normally open set of contacts. So it's just a different type of push button that we use, and we wire it into the circuit. So what we have to remember is we have to wire it into the opposite circuit. So let's take our forward start button for an example. So this is our forward start button. These are our normally open contacts on our forward start. If we want it to stop running in reverse and start running in forward, we're going to take a normally closed set of contacts associated with this button, and we're going to install it down here in my reverse stop circuit. So if we put a normally closed set of contacts there, which is associated with this button, whenever I press my forward start button, right, forward start button, I press that, it will open the normally closed set of contacts located in my reverse stop circuit, which will stop it running in reverse, and then it will start running in forward. Right, so that's a lot to take in, but my normally closed set of contacts opens in the reverse stop circuit, then my normally open set of contacts closes in the forward start circuit. It's just one push button with just one label. That's my forward start button. We do the same thing here. in my forward stop circuit, I put in a normally closed set of contacts associated with my reverse start button. So this is my reverse start button. I have a normally open set of contacts, reverse start. When I press that, it will open the normally closed, which is in my forward stop section, which will stop it running in forward. And then it will close down here, which will allow my circuit to run in reverse. So this allows us to be running in forward and then immediately stop it and run into reverse without hitting that stop button. Again, keep in mind, there is no reverse stop button or forward stop button. There is no reverse stop button. This is the forward start button and the reverse start button. So if we were talking about a push button station, it would actually look something like this. We would have a stop button there. We would have a forward start button. And we would have a reverse start button. So you can see this forward start button, when I press it, will close these contacts. My reverse start button would close these contacts. So again, when we're wiring this, we really need to follow through on the diagram to wire it correctly. I'll go through some wiring of this on another video. Thanks for watching.